This conference will now be recorded.
All right, this is the Math 136. We are just a couple examples away from where we needed to be so that you guys were ready for that quiz that's coming up. Especially the last example that I'm going to do in this video. It will help you be prepared for that quiz. It was the only question essentially that we didn't do together in class in terms of notes the past 2 weeks. So we have to cover two topics in this video. What is a complex rational expression and how do you simplify it? And then what do you do if you're trying to rationalize a radical in a denominator, but it is part of a binomial? So let's look first at the complex rational expressions. It says a complex rational expression is a rational expression that contains additional rational expressions in the numerator, the denominator, or both, essentially fractions within fractions. Techniques for simplifying: you can combine the expressions in the numerator into a single rational expression by adding or subtracting. Then you can do the same thing in the denominator by adding or subtracting. So in other words, the goal is to get one fraction on top, one fraction on bottom. Then that is now a numerator divided by a denominator, and we can rewrite that as multiplying by the reciprocal. So for example, let's look at this version. The bottom is already a singular fraction. Notice there's just one bar going across, but the top is two separate fractions. So we're going to get a common denominator by multiplying this first one by x minus 1 on top and bottom, and multiplying the second fraction by x plus 1 on top and bottom of it. That will give me 3x minus 1 plus 4x plus 1 all over x plus 1, x minus 1, and then that's all over the 49x squared minus 1 over x squared minus 1. Now we want to clean the top up by distributing this 3 and this 4 and combining any like terms. So that is going to be 3x minus 3 plus 4x plus 4 all over my denominator of x plus 1, x minus 1. We still have all of that over the 49x squared minus 1 over x squared minus 1. Okay, combine the things on the top. That gives me 7x plus 1 over x plus 1, x minus 1. Now, I'm already ready pretty much to flip this, so I'm going to go ahead and put a times because that top is now as simplified as I can get it. And we're going to times by the reciprocal of the bottom. So it's going to be x squared minus 1 over the 49x squared minus 1. And this is the time you would want to factor anything you can. In fact, this second fraction, it factors into an x plus 1, x minus 1 on top because of difference of two perfect squares. The bottom is also a difference of two perfect squares. It's a 7x plus 1 and a 7x minus 1. So when we look at this, we can reduce the 7x plus 1s on top and bottom since this is times, and that whole x plus 1, x minus 1 is gone. Now it looks like your whole numerator is gone because remember this is this factored. You're still left with a 1 on top no matter what. So this is a 1 over 7x minus 1. Please don't write 7x minus 1 and circle that, because if you don't realize it's in the denominator, you will have the wrong answer. So it's 1 over 7x minus 1. So that's how we deal with the complex rational expressions. Okay, the other thing that we needed to cover, and like I said, there wasn't much left to the notes, but I wanted to make sure you had them, is rationalizing denominators that contain binomials with radicals. The goal here is to find the conjugate of the denominator, because remember that is, and we'll make sure you understand what a conjugate is. A plus b and a minus b are conjugates. Means they are, when you FOIL them out, the middle sign or the middle terms will cancel out. Okay, so that's helpful because it helps us get rid of the radicals. So this is really kind of the factors of a difference of two perfect squares. So if you're trying to find a conjugate, you just take the same two terms and you change the sign in the middle. We multiply the numerator and denominator both by the conjugate to make the rationalizing step happen. We use the distributive property to work it all out, and then we simplify. So we have this first one here. This says that we want to get 6 minus square root of 3. So the idea here is that whatever we do, we should end up with no radicals in our denominator if we've rationalized it. So we're going to multiply this by 6 plus the square root of 3 on top and bottom to keep our fraction equivalent to itself, because otherwise you wouldn't be multiplying by 1. And then we distribute on the top, so this would be 18 plus 3 square root of 3. Remember, you cannot multiply those two together because this is an inside value, this is an outside value. They're different creatures. And then we'll FOIL the bottom, so that'll be 36 plus 6 square root of 3 minus 6 square root of 3. And then because we're doing square root of 3 times square root of 3, you can do that. That actually is negative times positive, so that's a negative. 3 times 3 is 9. So notice that one's going to be a perfect square. So on top, we have 18 plus 3 square root of 3 over 36. The middles are going to cancel. That was the whole point of the conjugate. And that's minus the square root of 9, which is 3. So we get 18 plus 3 square root of 3 over 33. And then here's where you have to check yourself. If there is a common factor in all of the outside numbers, we should reduce. So for example, we can pull a 3 out of the top and get 6 plus square root of 3 over 33. And the 3, since it's a monomial, can reduce with the 33 and leave 11. So my final answer is 6 plus the square root of 3 over 11. And now the goal was met. We got the radicals out of the denominator. So this one is just another version where now we have a binomial on both top and bottom. You technically could rationalize the top if you want. That is a skill we sometimes use in calculus, but we're not going to be doing that in our class. So the conjugate of this denominator is a minus in between them. So we're going to multiply that all out. Now we have to distribute. So on top, I get a 2 times the square root of 5, a 2 times a negative 3, so that'd be negative 6. A square root of 2 and a square root of 5, and it's a negative times a positive, so that's going to be negative square root of 10. And then negative times negative would be positive 3 on the square root of 2. So that's my top. And none of those are like terms because they have to have the same exact radical to be like terms. On the bottom, we get square root of 25. We get a negative 3 square root of 5, a positive 3 square root of 5, and then we get a negative 9. So the middles are going to cancel, and this is 5. So 5 minus 9 is negative 4. So we have 2 square root of 5 minus 6 minus square root of 10 plus 3 square root of 2 all over negative 4. Now, a lot of times we don't like to leave negative in a denominator, so one way to fix that is bring it out to the front and just leave your whole fraction as it is on top. That is one way to fix it, but you have to leave it out front if you don't change anything on top. The other option is to change all of the signs on the top. So that would make this negative 2 square root of 5 plus 6 plus square root of 10 and then minus 3 square root of 2. That also would take care of the issue, and this would then be positive. So either one of these versions would be okay with me. And that is the end of this video.